As coordinate geometry line revision sheet 1, question 4. The point P, 4 minus 3, Q minus 4, 9 are 2 points. Find the coordinates of the point which divides PQ internally and the ratio of 3 is to 1. It's the internal case. We have 2 points in a ratio. We go to page 18. We see a point dividing that line PQ in a ratio A is to B is given by this formula. We're going to label our points, write down our formula and sub in. Points are labelled and we're ready to sub in. Fill in your coordinates and simplify, and we should end up with the point minus 2, 6. Question 5. Find the measure of the acute angles between the line y equals 4x minus 1, y equals tx plus 3. Give your answer to the nearest degree. Angle between two lines is page 19, second formula from the top. Tan theta equals the positive and negative of m1 minus m2 over 1 plus m1 m2. The lowercase m's here, they stand for the slopes of the two lines. The plus and the minus is only necessary if I need two answers, and theta will refer to the angle between the two of them. We need to find the slopes of both our lines and fill them into that formula. To find slopes of lines, you rearrange them in the form y equals mx plus c. If it's in the form y equals mx plus c, which they've already done for us here, we can note that the slope will be the coefficient of x. So the slope is 4 and the slope is 2 in this case. When you sub those into your angle between two lines formula, you'll end up with the tan theta is equal to 2/9. But it's theta that we want. So we want to separate tan and bring it over. You remember from junior cert, that becomes tan inverse of 2/9. Make sure your calculator is in degree mode. That gives us 12.53 degrees, or to the nearest degree, that's 13 degrees. Remember, this formula finds an acute angle between two lines. That's the angle less than 90 degrees. So if that's 13 degrees as my acute angle, just remember vertically opposite, that will also be 13 degrees. If I did want the obtuse angle, just remember any straight line must be 180. So if this is 13 degrees here, the remaining angle here must be 167 degrees, 180 minus 13. Question 6. Show that the line containing the points 3 minus 6 and minus 7, 12 is perpendicular to the line 5x minus 9y plus 6. Our keyword here is perpendicular. That tells me straight away I need to look at the slopes. So I need to find the slope between these 2 points, and after that I need to find the slope of these lines and conclude that they are indeed perpendicular. To find the slope of a line between 2 points, use your slope formula, page 18. That's the very first one. M, lowercase m stands for slope, is y2 minus y1 over x2 minus x1. To find the slope of the line, we'll utilize our equation of a line, y equals mx plus c. For the slope between 2 points, label them x1, y1, x2, y2, and fill into the formula. Subbing into our formula, we end up with the slope of minus 9 over 5. Let's find now the equation of the line that they give us. And remember, the reason we're finding slopes here is because we're told they're perpendicular. It's a key word for slopes. So to find the slope of a line, rearrange it y equals mx plus c. That means it gets y on its own. So minus 9y, bring your x over to become minus 5x, and then minus 6. Minus 9 is dividing everything multiplying everything on the left, so we'll divide everything on the right. You can write them individually as minus 5x over minus 9, minus 6 over minus 9. And we can simplify that. Multiplying by 5 and divided by 9, minus divided by minus a plus, that's the same as multiplying by 5/9. So 5/9 of x and minus 6 over 9, again simplifying to a plus, and that would simplify to 2/3. So now we're in the form y equals mx plus c. We can see that the slope here is 5/9. The conclusion you need to be very careful of. To conclude that these are perpendicular, you can't just say one is upside down with the sign inversed. The proof for perpendicular is a slope multiplied by a perpendicular slope should always give us minus 1. So minus 9 over 5 multiplied by 5 over 9 should give us minus 45 over 45, which is indeed equal to minus 1. Hence, they are perpendicular.